First question from the audience for any of these guys.
Oh, hi Pat, how you doing?
Well, my question is, I grew up in Portland, and it's like everybody else. As you're a kid, you're sitting there, you know, suddenly you get this snowstorm in November or early December, and you get real excited, and you go, wow, it's going to be just totally cold winter. But it always seems that if we get an Arctic outbreak in November or early December, when it's unexpected things, that's the end of it. It's just, last year was a classic example. Any thoughts on that?
Mark says he has a smart-ass comment.
Well, I can feel the bus running over me, Jim. And you know, I had to argue with them both. I think the last two falls and winters, there were people in the newsroom that said, no, we can't call this the winter blast because it's not winter yet. So we call it the fall blast. I said, this could be it for the winter. I don't know why. I mean, just...
I'd have gone with winter plans. I'm a native of Portland too, and I can tell you on these snowstorms, something that works. And if any kids in the audience remember this, what you do is you look out the window, and then you close the window and you wait for 15 minutes, and for that entire 15 minutes you wish for more snow, and you go back and see if there was more snow, and it works.
Next question. Go ahead.
I apologize for this question, but does anybody have any theories about what makes the winds vary on the equator, the whole cause of this movement of water?
I think it's a cyclical thing. A lot of people think it's shifts in the trade winds which cause a change in currents, which causes a change in the distribution of the temperature. But then the question becomes what causes the trade winds to change. Years ago, I had a conversation with the late Bill Quinn, who, in my opinion, was one of the premier El Nino people. He'd been studying El Nino since the 60s. And I said to Bill, now, Bill, what causes El Nino and La Nina? And he said, well, George, I think it's changes in the Indian monsoon. And I said, okay, well, what causes changes in the Indian monsoon? And he said, well, I think it's El Nino and La Nina. Some people think there's a very strong tie-in with changes in solar activity. Kyle mentioned Theodore Landshut, who I also am familiar with, and who's pioneered a lot of that. But the short answer is we don't know.
Next question.
Hi. I need to know what the current SOI and MEI are. I can't hear.
O and I like minus 0.7.
Ron, I think the current MEI as of early October this year is about minus 1.7 or 1.8. I did an estimation here from my equations since we're almost toward the first hour of November, but it's definitely plunging quite rapidly like it was doing last year. Maybe not quite maybe as the depth of last year's MEI, but it's about roughly about minus 1.8 right now. I'm sorry. It's minus 0.8. So it hasn't crossed the La Nina threshold, but probably will by the time we get into November.
That's the MEI?
That's MEI.
What about the SOI?
SOI? I don't know, I think you're SOM.
Actually, to answer that question, I believe the last month, September, was about a +8 or a +10. But it's up above 0 right now, so well in the La Nina threshold. Would you guys agree with that?
Yeah, I don't know what it is off the top of my head, but the beauty is nowadays you can get it online, and you can get historical information online, and you can do the same kind of stuff that I'm doing, which is not huge number crunching stuff. It's not all that complex. I think we live in a great time now in that all kinds of information is available online to anybody who wants to analyze it and come up with correlations and theories. It's not difficult to get this information. That's partly why I don't know it off the top of my head, because I'll just go online and look for it.
Okay. Thank you.
Hey Ron, if, when all of our presentations are posted on the AMS website, I think by tomorrow sometime, actually I have a link to the MEI information there for that guy, Klaus Walter in Boulder, Colorado, so you can go with that and get that information there.
Okay, thank you.
I have a question. Joe McIntyre, and I noticed that you all have different employers, and I'm wondering how your weather forecasting methods and what you're looking for change according to who you're looking for. First got the idea when I heard about the tribal commission. I thought, of course, he'd be more interested in runoff than anything because of what he needs to get for the fish. But do you have similar types of different things you look for when you're doing your predictions? Thank you.
I think I can speak for Pete. We both work for the Department of Forestry, the Oregon Department of Forestry. And this kind of seasonal forecasting for the winter is of very little interest to the Department of Forestry. So for us, it becomes kind of a spare time, part-time thing. What they're interested in, what the Department of Forestry is interested in, is summertime weather. And so hopefully some of the techniques that we come up with for forecasting long-term allow the Department of Forestry to pre-position resources. They contract for helicopters and tanker planes and so forth. And if we can reliably say, like for last summer, if we could reliably say it's going to be a slow start to the fire season because it's a wet spring, but it might be a longer end. They won't start those contracts until later, and actually save you money, save taxpayers money. Actually, they're saving forest landowners money because it's all paid for by fees that forest landowners pay. But that's the sort of thing we're doing. So the winter forecast is just kind of, Pete and I just do it for fun.
Your tax dollars do pay for my forecast. No, I work for the National Weather Service, and again, just like these guys, most of my concerns day-to-day are day-to-day forecasting the next few days. Climate prediction is generally handled by the National Climate Prediction Center, and so I'm kind of just more of a messenger for them and maybe an interpreter for some of their information. So we're just kind of tied in with basically what the Climate Prediction Center says.
My employer encourages me to do whatever I want to do. And usually we see eye to eye, but not always.
I guess maybe I'll add my 2 cents worth that for us, for the tribes and all the salmon restoration efforts across the basin here, probably our critical period is April through September, which is the main fish passage season as far as the baby salmon, the smolts moving toward the ocean, and the adults returning back up at the same time. So seeing how much water is in the river and the times of year is really critical to make sure those salmon get to where they're going.
We got one here in the back.
I have a question about, I'd like to know, how do the oceans hold most of the warmth on the planet? And how do the oceans affect weather? And then a third question for Kyle, I hope you have an answer. Why and how does water divining work? Water leaching?
That's a new one for the list. Next year.
Just by the very nature of water, it holds a lot more heat than air does. The specific heat of water is much, much higher. The biggest source of terrestrial heat to the atmosphere is the tropical Pacific, because it's a very large area of very warm water. And unlike what happens in Las Vegas, you know what to say about Las Vegas, what happens here stays here. What happens in the tropical Pacific doesn't stay there, it goes everywhere. And changes there in the sea surface temperatures affect evaporation, but they also affect the heat being liberated to the atmosphere, and it has a tremendous effect and literally affects every continent in a big way. So that's why we keep looking at the tropical Pacific, not just because we're on the Pacific coast, but because it really literally is an incredible global phenomenon.
Got time for about one more, so it's really big ask.
Question for all of you. The science is absolutely interesting, but the application of it is really where it's all at. Wouldn't you agree? I have used George Taylor's information when he was the state climatologist to actually set up emergency operations ahead of time because we were going into a La Nina event. Last one we did was in 1999 in the Tillamook area, and it was all statistical. But what I want to ask you guys is, can we, with the product and with all of the research you're doing, can we do a better job of predicting what drainages could potentially have that record rainfall, so we can give notice to the jurisdictions that, again, they should be better prepared this particular winter versus another winter?
I don't forecast the whole winter, so it's up to these guys.
I think what the gentleman's referring to, we actually do have some pretty good models and forecast techniques, but the problem is that downscaling. We're going from really big picture models in the atmosphere down to both regional and local scale. It's something that certain people like the University of Washington's climate impacts groups and others are trying to use new techniques, both deterministic and probabilistic and statistical nature, to downscale down the basin level. That's still a work in progress. So we do have some new results, but it's still a kind of experimental basis. We hope the next few years be able to get more pinpoint accuracy. I do know that the Weather Service with the local river forecast center are able to pinpoint that more on a short-term basis. But as far as going out like 3 months, that's still kind of borderline science fiction right now. But you know, I think the Weather Service is working to improve upon that process. So keep that thought and check back with us next year.
Real quick, Jim.
Yeah, that was a very good question, and it's the application of weather sometimes that's more important than the weather forecast. Weather forecast does not have to be perfect to be useful, have utility. And as I mentioned with the seasonal forecasting for the Department of Forestry, we don't have to be perfect, but if we can tell those people don't sign the helicopter contract until June 15th rather than June 7th, it's thousands of dollars that can be saved. And okay, if we're wrong a little bit, then they have to rent the helicopter on a day-to-day basis, and yeah, it costs a little more money. But if we can do that consistently, save them just that 7 days, we can save them a lot of money. And even if the forecast is not perfect, we can save a lot of money. And the application of forecast information is an area that I think really lags. And I'm not sure there's a whole lot we can do about it as weather forecasters. It's a synergistic thing with the forecaster and the user.
Well, what you're saying, Jim, is absolutely appropriate. And for fire, it works for floods also. Again, going back, I'm less familiar with the Corps of Engineers. My primary focus is flood damage reduction. And so much of it is based on if you can trigger people quick enough, they have an opportunity to build barriers and channels to protect businesses and all that. When I went back to George back in '98, I said, okay, can you tell me what kind of events occurred, or climatic situations occurred, that caused the 1948 flood, the 1964 flood, the 1972 flood. And he came back and he says, you know what, it's interesting, there's kind of that neutral period where they can't figure out if it's going to be La Nina or El Nino or whatever, and that was in fact our trigger for starting 2 of the advanced measures projects way ahead of time. In both cases, we were able to complete the work prior to the Thanksgiving flood in Tillamook County in 1999. So anyway, I was just wondering if anybody was doing that kind of, again, that analysis of, okay, what kind of conditions are preceding these major flood events, these major fire events, and things like that, so that we can actually use that at the local level to help them overcome their particular, or at least be better prepared for that particular winter.
Guys,
One of the things that I'll say,
we got
Les,
around 15 seconds, please.
15 seconds.
Yes, Scott.
One of the things I'll say, Les, talking real fast, is that the more extreme the event, the harder it is to predict in advance. You can do general kinds of things. You can make climate predictions for a month or a season, but pinpointing extreme events is really hard. But what's changing is the frequency. If you have a 1 in 100 year event, that's a 1% chance in any given year, and maybe in a certain year it's 2% or 3%. It's still a low percentage, but maybe an increased risk of that low percentage event happening.
Sorry that was fast. I want to encourage you guys, if these guys stick around until 3 or just shortly after, they'll be hanging out. You can pull them aside and ask them some questions. We got to fly because we're already into the second half. Thank you, gentlemen, for coming up to the stage.